Hey everyone, my name is Joshin Sam, and today I'll be talking to you guys about raycasting in AR. Um, so you might be wondering what even is raycasting. Raycasting is basically an invisible line from a point to 3D objects, 3D space to detect intersections so that we can place and select virtual objects in the real world. Without raycasting, it will be difficult to have a meaningful interaction between digital and physical realms. So you might be wondering how raycasting works. Initially, an origin point is set, and it determines where the raycast ray travels from the origin point, and then it would detect collisions with virtual or real objects, and then it would, once it is hit at any location, it would return a hit position, the distance between the distance of the raycast and the object information, whether it's a sphere, polygon, something like that. And then the mathematical principle behind this is pretty simple when you think about it, because the formula that is used is basically just a line. P is equal to O plus TD, where O is the origin point and T is the distance parameter and D is the direction vector. So there are three types of intersection types detected by raycasting object. One is a plane, which is used by a simple dot product, and then a sphere, which is used by which is calculated by a quadratic equation, and then polygons. Then you, how raycast works in an AR environment. It The user detects or captures a real world imagery, and then the AR system analyze the scenes, and it would detect planes and features from the image, and then a raycast is projected to detect intersections. If any of the raycast detects any of the virtual content anchored at any hit position, it would return the object information. So there are three types of core algorithms and techniques which can be used so that to make it better, to make it more um, to make it more efficient. In the first thing is acceleration structures. It is used to optimize, organize the virtual in a smart way. It doesn't have to check every raycast one by one. Instead, it will uh, focus only one areas where a hit is likely happened, and then we can use collision detection. It is how we detect collisions in AR objects, which can be uh, used by geometrical tests to figure out if the ray touches any objects. And then finally, to make it more efficient, and we use bounding volume hierarchies, or BVH. Think of these like a set of Russian nesting dolls, large containers that will hold smaller and smaller ones, and so on. When we cast a raycast, it first checks these outer containers, and then it would decide if it wants to go inside it. It is used for uh, efficient testing for nested containers. Then these are the real world AR applications used by AR raycasting functionality. So one thing that just came up was virtual furniture placement. I'm sure you guys have seen in Amazon, where you can place couches in a real world that they uses raycast for it. We can use it for industry training to interact with virtual equipment in actual workspaces. We can also have it for indoor navigations too. There are technical challenges and considerations when we utilize raycasting. One of them would be detecting hidden objects and proper depth sorting. It can also have problem with rendering correct visual cues. There's also a fine balance with accuracy and speed. It also consumes a lot of battery because of the limited mobile processing power. There are things we have to consider when we utilize raycasting. Finally, in future, I believe that we be able to have better tracing chips in mobile devices. We'll also have see AI integrations to make it more s- smarter and be able to predict and detect things in virtually in AR environment. And then we've already seen AR glasses introduced by Meta. We'll be able to see raycasting from just eye tracking. We'll be also seeing cloud computations because we'll be offloading all of these complex calculations from the backend of a mobile device. Then we'll be moving all of those to the surface to make it more efficient. And this is the presentation, and thank you.